Okay, so for the next section of the day, up until lunch, we've got three short talks. The first is from Sean Leach from Rodgers Leask, who we've worked with on the engineering, geology and hydrogeology module this recent spring.
Thank you. Hello everyone. First of all, an apology, because it's a pretty tough gig following Adrian's whiz-bang presentation. I mean, to you geologists, mine's going to look like gardening in the top 5 to 10 metres with a bit of groundwater thrown in, but stick with it and hope you find it interesting. I'm just going to give you sort of SME's view on innovation in the sort of civils and engineering arena, based on my experience with a small company. I've worked for both the corporates and small companies, and they both got their good and bad points. But it's nice to find that SMEs like to innovate. My own background is I did an earth science degree in, seems like a million years ago now, in 1983 at Oxford Polytechnic. And then after that I worked on the Channel Tunnel for 4 years, 5 years underground, digging towards France. I did a master's in hydrogeology at UCL, then worked on the deep hydro testing at Sellafield, so boreholes down to 1 kilometre depth and working with low flow environments, which is interesting. Worked on the environmental protection of foot and mouth, the burial of all the carcasses, things like that. And then HS1, worked on that, and spent last 10 years at Longbridge in Birmingham, remediating 400 odd acres of brownfield site, really. So that's my sort of background. But so Rodgers Leask, an SME is defined as a sort of non-subsidiary independent business with generally less than 250 employees. Rodgers Leask are consulting civil, geoenvironmental and transport planning engineers. We're independent, so we fit that criteria. We've got multi-sector experience. We operate on a national basis. And we've got about 60 engineering and technical staff. And even though we're small, we try and get involved in innovation, really. These are just the sectors we work in, industrial, distribution, all the way through. And these are pictures of actual projects, Rodgers Leask projects, apart from the nuclear one. That's in Russia. We didn't work on that, but our nuclear clients won't let us show any pictures of their installations, so just made one up, in case any of you spotted it and knew where it was. Innovation for us in civil engineering, I know it's a bit of a cheesy picture, but it just sums it up in that, you know, we are digging stuff out of the ground, we're introducing foreign material, we're affecting the hydrogeological regime, and we've got to try and do that with as much environmental protection as we can bring to the project. In terms of RLE, there's sort of 3 areas that we're looking at the moment. One is Triton, the other is PowerSem, and the other is MagMols. And Triton and PowerSem are actual the things that have been developed by other people that we've tried to bring in to our regeneration projects. And then the third one, MagMols, is more exciting for us because we're right in at the beginning and we're trying to bring it to market, as it were. So Triton is, I don't know if you're aware, but whenever you do a redevelopment project, you need to look at flooding and your effect on localised flooding. And everything's measured in relation to the sort of greenfield runoff factor, so water percolating through superficials into rock with a long transient time to travel. When we do engineering, it's hard surfaces. Water moves rapidly into the rivers and streams and can cause flooding. So we have to try and attenuate that. And there are lots of systems around, but we seem to like the Triton system. And we joined them and became their certified design engineers. And the thing we really liked about it was the green credentials it had. It's the units are constructed from a soya-based resin as opposed to plastics from petrochemicals. They're effectively carbon neutral when we look at them in terms of the project. You can adapt them so that you can apply contam filters, and generally we end up using less quarried stone on projects. So we like that. So effectively you can see these units in the ground with a stone casing, and they'll be covered over and form a car park, but all the surface water will be run through that system and then delayed before it goes into the wider river network, and hopefully be better quality as well. In terms of PowerSem, this actually uses, cement additives have been around for a long time, trying to improve the engineering, performance and materials. But recently they've really looked at nanotechnology to improve their performance. Because previously the industry has suffered with a lot of snake oil salesmen in the past, where it just hasn't delivered in terms of performance. This has been developed in Holland, it's been used wisely in South America and the Middle East. Acts on a molecular level, unlike other cement additives, which tend to just act as a very coarse structural binder. The advantages is we can reuse really poor material on site. Way back, material was just excavated, moved off site, dumped somewhere, fresh aggregate was brought in to provide a platform to build off, but we don't need to do that now. It preserves raw materials and aggregates for future use. We get great reduced build times. When you guys, if you ever start working on big projects, time is of the essence, time costs money. So anything you can bring to the project to reduce that is good. Reduce import-exports. I mean, contaminated material, I don't know now, is about, I think it's about £250 a tonne. Is that right, Rich? To get rid of. So if you're moving hundreds of thousands of cubic material, it's a huge saving. And there are different types of products available that we try and use. And we're a UK representative for this company. We've joined up with them and we formed PowerSem UK. So the main products we use, there's RoadSem, that's used to increase soil strength. It's used for generating secondary aggregate for roads, pile mats. It reduces off-site disposal and maximises reuse. Also, this product can be ploughed back into the land if they're only temporary haul roads. And there's lots of testing to show that even though you start off with a high pH, it does buffer back in time. And it's acceptable to the just to move it back into the ground. There's InnoSem, which binds in contaminants into the soil structure and can be, again, used for pavements. We've had quite a good result with the Highways Agency, looking at the reuse of blast furnace slag, which generates a lot of mobile sulfates, causes problems in terms of concrete cancer. But we've got the leaching testing to prove that it's not mobile. We'll be using it on a lot of projects and reusing what would be a waste material. Then there's ConcreSem, which improves the performance of concrete in and structures, reduce curing time. And an interesting one is it increases the temperature resistance of concrete. We've all seen Grenfell and fires, how terrible they can be for structures. Concrete sort of spools around, I think, 1300 degrees, but adding PowerSem pushes that up to 1800. So sometimes it can mean the difference between having to totally demolish a building and leaving something you can work with after a fire. Just a couple of pictures showing it being used. Actually, this is out in Egypt, Suez Canal area. You can see this operative on the right is standing on the existing soil material. It's very low shear strength, very heavily rutted, just not suitable for development. Then PowerSem's been added on the left, and they're actually creating a road, an access road, and improve the engineering performance of this material so we can use it. This is in the UK. This is one of our projects. Again, we can't say the name of the client, but created a huge industrial park. There were lots of poor clays and man-made material, high in organics, not very good for building off. We've applied PowerSem, created a good platform, zero material going off site, saved the client a fortune, and he can now build his big warehouses and sheds on it, which is good. It is interesting when you talk about nanotechnology and then it does look very agricultural, but it does work. I've had an interesting discussion with HS2. They're going to be excavating millions of tons of soil and made ground along their route, and they're looking how best to reuse that material, ideally as engineering fill. In some of the phases of HS2, they're going to go through high sulfate ground, and they're going to encounter contaminated ground. And we approached the innovation team to talk about using PowerSem on the project. They've looked at the information, they think it's a good product. But we came across one of the frustrations you can have with something that's new, in that they've placed the construction risk with the contractor, and the contractors are used to using certain products. They're not quite sure about PowerSend, they haven't used it before, so it's probably not going to be used on phase 1. They're going to stick with the proprietary products they've got that they know. But in phase 2 and phase 3, we're trying to say to HS2, why don't you have some test panels running in parallel, so in the next 5 to 10 years you can get enough data, contractors are going to be happy, and they use the material. So it's a case of watch the space, really. The third area that we're looking at is magnetic moulds, or mag moulds as it's nicknamed. One of the problems you have in groundwater and surface water treatment is it can be a bit non-selective or non-specific. You might want to remove cadmium or something, but take the cadmium out, but you also take out molecules of a similar size. You might take calcium, magnesium, some of those things you want to keep in an effluent when you release it. We were looking at getting into the nuclear decommissioning industry, and we met a small company called ProNudec, and they specialise in decommissioning reactors, old reactors. They did one in Bojnica in Yugoslavia. What they do after the fuel rods have been removed, they actually strip out the fine layer of contamination that sits within miles of copper piping forming the reactor core. They remove that, and then the copper can be reused, whereas before it was just packaged up and sent away to high-level waste disposal. And they were using a basic technique to try and strip out 1 or 2 of the radionuclides from the fluid. And we thought, well, could we try and apply that in conventional groundwater surface water treatment? So we formed a joint project with ProNudec and Reading University, but fine. And we're looking at creating specific magnetic molecules to target specific contaminants. And they can separate out the metal ions from solutions, strip them out. And very simplistically, the magnetic molecule just has 4 parts. It has a magnetic core, it has a protective coating to protect it based on from the environment that it's going to be released into. It's got an organic linker that then fastens on the active part of the molecule, which is developed in the lab, added on, and then used to strip out contaminants. In terms of process, there's 2 main types of molecules we're working on. One is calixarine, and the other is BTBP. And calixarine is very good when we adapt it to remove radionuclides from solution. But BTBP removes metal ions, and that's where we're looking more for the conventional use, in what I call conventional remediation. The extraction process is really very simple. Your contaminants are mixed with the fluid, you apply the magnetic molecules in solution, apply a magnetic field, and that pulls the bound contaminants out of solution, as you can see just on these simple bench scale tests. Left you can see the mixture, and then when the magnet's applied on the right, it effectively pulls the contaminants out of solution. And then in a full process you'll degauss that and remove the contaminants. So bench scale results we've had have been really good. 70 to 100% removal of all of those ions. In some cases we actually got more than 100% because we found it was removing impurities from some of the additives we're putting in, so it showed it was quite an effective technique. We now need large-scale pilot testing, so we're in discussion with a lot of companies about how to try and bring this to market and make it useful. Parties that are interested, we're talking to water companies. They're particularly interested in the removal of manganese from their pipe work. It adds an odour and a taste issue as well to their supplied water. We're talking again to HS2, looking at their temporary and permanent water quality issues related to temporary works, dewatering as they're constructing, and then long term you're going to have track bed discharges from particularly phase 2 that travels through the mining mining areas through in the north of the country where you're getting mine water issues and rising mine water issues. I'm also talking to the Coal Authority about some of their metal mines drainage. So I think it's just been a bit of a whistle tour through some of the things that Rodgers Leask are looking at as a small company. Ideally, we'd like to find a project where we can attenuate the groundwater with Triton, do lots of binding of contaminants with Harrison, construct structures with MSM and Concresem, and then have, say, reactive barriers where we could use funnel and gate systems for controlling contaminated groundwater and polishing it off. That's what we're trying to get to. So, in summary, all companies can innovate, whether they're large or small. Sometimes SMEs have got a vital role because they tend to be less bureaucratic, willing to take a punt and a chance on something. There is going to be frustration because ideas are just ideas until you get them to market. We already see obstacles on HS2, even though they want to embrace innovation and they do try. Sometimes flagship projects are not the best place to test something like this, because if it fails, it would fail big time. Don't be scared to put your ideas out there. Seek out innovative solutions to use during your careers. You might even invent a few. And good luck. Thank you.